Hey guys, welcome to another video, and today we're looking at density, right? So density tells us how compact the masses in an object is, right? So if we look at these two diagrams here, A and B, they're both the same size, right? And their masses now are the white circles. Now the red circles are. Now if we notice, the red circles in A and B, they're of different spacing between each other. So in this case, we would say that object A will have a higher density. And why? Because it's more compact with the masses, right? Now these look similar to what you learn in chemistry if you do chemistry for the states of matter. So this looks like a solid state and this looks like a liquid state, and that's how we know that solids have more density than liquid or gas, right? So once the particles are very close together in regards to its volume, then it has a higher density. So if it's two same objects but their masses are spaced differently, then their density will be different as well. So in this case, density, which is rho, right? It's not a P, right? So it is it's a Greek symbol, that's rho. So it's a slanted P, right? So not a straight P. This is something else, right? So it's a slanted P, which is equal to mass over the volume. So the unit mass is kilograms, volume is meter cube. So kilogram per meter cube, right? But also you see some books having it as grams per cm cube, right? So it's the same, but once a question asks you for the SI unit, then you use kilogram per cubic meter. And what that tells us is that our mass should be in kilograms while our volume should be in meter cube. If it asks you for gram per cm cube unit, then that means your mass should be in grams and your volume should be in cm cube, right? And that leads us to how do we move from meter cube to cm cube, right? So let's say we're given 2 cm cube and we need to change it to meter cube. How do we do that? But we know that 100 centimeters is equal to 1 meter, right? So to move from this centimeter to centimeter cube, we cube here, right? So if we cube the left side, we do the same to the right. So if we cube 100, then we get 1 million. So we know that 1 million centimeter cube equals 1 meter cube. So most students normally write this, which is 100 centimeter cube equal 1 meter cube. That's not correct. It's 100 centimeter equal 1 meter. So we need to find how much centimeter cube is. We cube the 100 as well, so we get 1 million, right? So that's how you convert between centimeter cube and meter cube. Now if we look at this example, if a box has a length 5, width 2, and height 2 centimeters, what's the mass? With a mass of 15 grams, find density. So density is mass over volume, so we'll write back the equation. Now our mass, we're going to change it to kilograms, so we divide by 1,000, and then our volume, we change each quantity to meters, which is to divide each by 100, and we get those numbers, divide, and we get 750 kilogram meters per meter cube, per cubic meter, right? So density is one of the easiest topics in physics, right? So we're going to look now at relative density, and relative density tells us about how much more denser an object is more than water or any liquid that is being compared to, right? So the density is equal to density of object over density of water, right? So in this case, it's the first quantity in physics that you encounter that you know to be dimensionless. Right? And the reason why it's dimensionless because it has no unit. So relative density is dimensionless because it has no unit. Let's see why. So let's say the object before, which is 750 kilogram per cubic meters, right? And it's being divided by the of water, which is 1,000 kilogram per cubic meter. So if we divide the numbers, we get 0.750. But what happens to the unit? Our units get cancelled out because both units are the same. Right? So therefore, we get a number that has no unit, so we call it dimensionless. Right? So this number tells us a lot about the object itself. So if we're comparing this block from the previous question to water, because this number is less than 1, so when relative density is less than 1, like in this case, then that object will float in. And in this case, will float in water, right? Now, if it is greater than 1, then that object will definitely sink, right? So this is one way how you can actually explain why objects float or sink depending on their density. There are other ways that we'll look at in the future, but one way, the first way that you're going to learn is about the relative density. So if you find the relative density of the object compared to the liquid that you want, if that number value is less than 1, then it's going to float. If it's greater than 1, then it's going to sink. All right? So thank you guys. This is all about density that you need to know at this level. See you next time.